Hi guys, welcome back. I hope you are refreshed. So now we are going to try and apply all of what we've spoken about so far to proof, right? But first, we need to understand what this proof is all about. What do I mean when I ask you to prove something? And what do you need to do in order to write the proof, right? Let me repeat that again. What do I mean when I say prove something? And what must you do when writing the proof, right? So let me just show you what I'm talking about. Now, when you talk about proof, right? When a question says to you, prove that, the other word they normally use is also show that. This means that you need to give reasons why the statement is true, because the statement is true. Why the statement is true? Because the statement is true. It's not that I am saying you need to prove something and then the result might not be what I'm trying to say, right? The reason why the statement is true. And then for you to do that, this giving of reasons that I'm saying you need to do is therefore what we call the proof, right? So this will be the process that you write down. And the process will always be what? You having a statement, right? You give me a statement there. And then with the statement, you will therefore give me a reason why that statement is true, right? At all times. Not things like adding numbers or subtracting numbers. That's just basic algebra. But if you claim that angle A is equals to angle B, how do you know that? Why do you think that is the case if you were not told, right? If it was told in the statement, then you will always say my reason is given, right? But if it's because of a certain property that you know based on those two shapes you're talking about, you will also need to give me that reason and not write given there. So if I did not tell you that angle A is equals to angle B, you can use the statement, the reason given. You will need to tell me why you are making that claim, because this is a very big claim, by the way. I did say to you that an axiom is a baseless statement that we make that we're going to try and find reasons for in order to validate it. Now, if I am given in the sketch A, B, and C, D intersect at E, what does that mean? It means that these are straight lines, right? These are straight lines. And if these are straight lines, then you can consider things like vertically opposite angles, right? Because you can only talk about vertically opposite angles if the lines are straight opposite angles. You can also talk about adjacent angles on a straight line, which is just revision of things that you know, right? Adjacent angles on a straight line, right? You can only think about these things based on the fact that I'm telling you that A, B, and C, D are straight lines that are intersecting at E, right? So this is my A, B, and that is my C, D, right? Because at times you'll find that it's like that and it goes like that, where E is here and then my C is there and my D is there. This is not a straight line. Yes, DE is a straight line and CE is a straight line, but DC is not unless I make that statement there. So I hope that clarifies what I'm saying. Also, when I say to you AB, DB, and BC are drawn, I'm also still going back to that statement of mine to tell you that these are straight lines. EF is drawn, also a straight line, such that, or so that E1 is equals to A. So what do I know? E1 is this angle here. There I'm told that it is equals to that angle there. And then also E2 is equals to C. So this angle here will be equals to that angle there. And then I am required to prove that E3, which is this angle, is equals to A plus C, right? Which is this one here plus that one there. Now, Whenever we have this kind of a problem, we start by filling in the diagram, right? Filling in the diagram, the information that you are given. So you can see I filled it in the previous question here where I was reading the statement. That's exactly what you need to do in your question paper or in your textbook if you are trying to do some homework. And then to apply all of this will then be the deductive reasoning that we are going to make, right? But now, with this deductive reasoning of mine, what must be at the back of your head when you're trying to answer this question is, what is the relationship of A plus C, right? The two angles, if I add angle A and angle C, can I make a statement based on that and give it a reason why I think that statement is true? That's the whole point of deductive reasoning, guys, is to say, can I make a statement, which is my axiom, and with that statement, I must validate it by giving it a reason based on the properties that maybe I was told when the question was starting. And that's the whole point of deductive reasoning. So, with this one here, I must look at what angle A is, right? I was told that angle A is equals to angle E1, right? I was told that angle C is equals to angle E2, right? So as a result, this is the same as having angle E1 plus angle E2, right? And you know, the reason for this will be because I am given this statement based on the first thing that I said, right? So you can even start by first claiming that A is equals to E1 and then C is equals to E2, and your reason for that will be given. So this is what I really mean. Let me show you, because then you won't be drawing those errors for me there for a proof. So you will start by saying A is equals to E1, and you will say C is equals to E2. And both of these are because they were given on the statement, right? As a result, I know that A plus C will be equals to E1 plus E2, right? For this, I don't really need a reason because it's just the deductive reasoning that we are using. Then I can make a claim, say, now I know that E1 plus E2 is equals to E3, right? And the reason for this will be because they are vertically opposite angles to one another. Now, do you understand what this means? Thus, which is what I want to now conclude, I will then say that A plus C is equals to E3, right? And you wouldn't really need a reason for that because it's part of the reasoning that we were talking about. Now, another type of a question that we have here will be, if they say sides HL and IH of a trapezium, right? Now, we need to look at the concept of a trapezium. What is a trapezium all about, right? One pair of parallel lines. That's what a trapezium does for us, right? So you therefore need to think about what? You need to think about the properties of parallel lines before you can even go anywhere. So you see, what I did was I just read the statement. Based on what I'm told on the statement, I'm now filling my head with some information that I must know already before I can talk about what the question wants me to do. So they are telling me this is a trapezium. Okay, what is special about a trapezium? We know a trapezium has one pair of opposite sides being parallel to one another, and then the other sides we don't really think much about them. So as a result, you can think about the properties of parallel lines, which is your corresponding, your alternate, and your co-inter. And that's how deductive reasoning works. You see, so it's not a think that I must already know what all of these are all about. No. It is because of the little things that you are being told that you are going to apply here in order to try and solve this, right? So let's see how we are going to do that. So we know that we are told that H1 is equals to L1, and this is something that we are told in the statement, right? And we also told that LH is parallel to KI, which is one of the properties, or rather, which is the property of trapezium. So even if we're not really told that, we would know that those are the two parallel lines, since this is a trapezium. Now, to use this, we need to try and link K with something that will, at the end of the day, help us to locate K with I to be equal to each other. So what do I know from this diagram? I know that K is going to be equals to L1, right? So K will be equals to L1, and my reason for this will be alternate angles, but remember, you don't leave it there. They are alternate because GH is parallel to KI, right? Some people might not use GH, they might use LH. They both lie on the same line. That's just one line, so it does not really make much of a difference, right? So I know the statement. But from this, what also do I know? I know that L1 is equals to H1, right? But L1 is equals to H1. And what is my reason for this? I was told in the statement. Not that you must write I was told here, because you write given. And as a result, I will then say, I know that H1 is equals to I, because I'm trying to link the K with the I, and my reason for this will be, these are corresponding angles, but they are corresponding angles because GH is parallel to KI. Guys, if you don't indicate these parallel lines, then your reason will be incomplete. Then I can now say safely K is equals to I, right? And my reason for this will be because they are both equals to H1, which is what we initially spoke about. But you wouldn't really need to write that reason here, because you would have used the deductive reasoning of, I started with the first statement of I know this, alternate. I know this, I am given. I know this corresponding. If I link all of that, then I can claim what they want me to prove, and I will be done. So that's how you therefore use deductive reasoning to try and prove some questions in geometry. All right, guys, that's the end of what we have to do for now. We just need to take a quick ad break, and when we come back, we'll look at some more problems together. Please stay tuned. I'll be back just now.